Hey there, I wanted to show you how to factor difference of two squares. It's an important one because it shows up a ton on standardized tests and on tests like your teacher will make for you after you've already learned factoring. And if you notice that it's difference of two squares, it's really fast and really easy. And if you don't notice, you end up wasting time on a test or on a problem that you didn't have to waste. So let's take a look. Difference of two squares, like I said, you want to get really good at spotting it. And a lot of the times it can be pretty easy to spot. So this is a classic difference of two squares problem. Notice that it's a difference, meaning it's a subtraction problem, right? And each of the terms are perfect squares. X squared is a perfect square, 9 is a perfect square. So it's the difference of these two squares. That's where it gets the name from. Factoring it ends up being really easy. It just ends up being the square root of x squared, that's x, and the square root of 9, that's 3. And you add on one side, add on one of the binomials, and then you subtract on another one of the binomials. You may have noticed, difference of two squares, it doesn't have that middle term, right? So there's not like a, x squared plus 3x, plus 9. There was no middle term to this problem, right? So if we'll look at why that is in just a second. But for some people, when they see that middle term gone and they don't think of difference of two squares, they're like, wait a second, how am I supposed to factor this? I don't have that middle term. So anyways, this is how you do that. I'm just going to expand this answer over here really quick, just as a check, and also to convince you that these two things multiplied together really do equal that. So we'll FOIL it. First, outside, inside, last. First, outside, inside, last. And notice that those middle terms, they cancel out, leaving the thing that we started with, okay? So that's difference of two squares, where the sign alternates like that, but otherwise the two binomials are the same, and then the middle terms end up canceling out, okay? Let me give you another example, just a really fast one, okay? X squared minus 16. Okay, great. It's the difference between these two. They're perfect squares, so right away, your brain should be going, okay, this is a difference of two squared problem. And you just take the square roots, that's x and 4, you make one side positive, one side negative, and you're done. That's how fast difference of two squares problems should be. As soon as you notice, it's really quick. So let me give you another example. How about like 4x minus 4, okay? The difference of 2, perfect. Notice that in this case, the square root of that, that should be squared. The square root of that left-hand side is 2x, and the square root of the right-hand side is 2. And so it's really fast, nice and easy, okay? So look out for these. Anytime you see that middle term's gone, you can see, well, maybe it's difference of two squares and I can do something like this super, super fast. Now, I actually want to show you a couple really quick examples that will illustrate that you actually don't even have to have perfect squares in order to be able to use the technique. You really just need the difference between two things, and then you can work out the square root. So for example, if you had x squared minus 5, at first glance you might not go, that's a difference of two squares problem because 5 is not a perfect square. But you can still factor it that way if you want to. Sometimes in some kind of problems it's useful. So I'll take the square root of x squared, that's no problem. And then the square root of 5. So plus square root of 5. Then x minus square root of 5. And just like before, I'll prove it to you, since it might look a little funny. I'll go back the other direction on this. FOIL it. First, outside, inside, last, and the square root of 5 times negative square root of 5 is negative 5. Then these terms end up canceling out. So I really do get that x squared minus 5 that I started with, okay? The other thing that you can do is you don't even need the difference. Check it out. Suppose I had x squared plus 7. Again, this is not normally the kind of problem that you would think, oh, I can do difference of two squares on this. But you can. You could say, okay, well, I could call that x squared minus a minus 7. Okay? And so I could just follow the rule, say, okay, I'll take the square root of the left-hand term, square root of x squared is x, and plus the square root of the right-hand term, square root of negative 7, then x minus the square root of negative 7, and that will work. Those two binomial factors really would multiply together to equal this. Anyways, so I think that that's all the examples I had for you. Hopefully, going through this difference of two squares will make it nice and easy for you to pick these things out going forward when you see them on the test. Like I said, definitely spot these ones, because if you notice them, they end up being the easiest ones you can do. All right, have a great day. See you.